Okay, boleh dengar suara saya? Hello? Okay. So for this chapter 2, okay, we will discuss on the compressibility and consolidations. Okay. You just imagine that when you have a land or ground, okay, then we plan to construct for any building, okay, and then for the footing itself, okay, we may apply a certain load on the top of the footing, okay. And in design, we may use the allowable load, okay, which is called as a design load. Then we may allow for the consolidations, okay, to occur, okay, with a limitation less than 25 millimeter. Okay, so if from your calculation, okay, if the settlement is greater than 25 millimeter, okay, um, actually your building is safe, okay, but it is not can consider uh, a good looking building, okay, under the serviceability limit state. Okay, so in design we have two type of limit state or design that we should cater. Okay, the first one is the ultimate limit state, okay, and the second one is the serviceability limit state, SLS and ULS. Okay. So for this compressibility and consolidation, okay, it's very important, okay, because you need to determine what will be the value for the settlement. Okay. From there, you may know either your building is cater for the SLS limits. Okay. So a little bit brief introduction on the settlement. Okay. So if a structure is placed on the soil surface, then the soil will undergo an elastic and plastic deformations. Okay. So I guess most of you know, okay, when we discuss on the stress strain curve, okay. So for example, this is stress and strain curve, okay. So for soil, normally it behave like this. We call it as a ductile failure. Okay. So if we load the soil, okay, up to a certain yield point, okay, so it may reach the plastic condition. Okay. However, when we load the soil, okay, for example, we using the design load, okay. So the design load should be in the range between between the 0 to the yield point. Okay. So this is can consider as an elastic area, while this is we consider as a plastic conditions. Okay. So in engineering practice, the deformation or reduction in the soil volume, okay, is seen as settlement or heave, depending on either the load is increased or decreased. Okay. Yeah, the same example, okay, when we apply a load on the soil, okay, under, for example, a footing area, okay, a square footing area, okay. So when we apply a load, okay, the load, the soil will deform, okay, a little bit down, okay. So this we consider as a settlement behavior, okay. And at the same time, okay, there will be a movement of soil upward, okay, adjacent to the footing, okay, and this behavior we call as a heave condition, okay. So another uh, way to explain settlement and heave. Okay, so this behavior we call as a settlement. Okay, due to we increase the load on the top of the soil. Okay, while for the heave, okay, when we reduce the load, okay, after we have previously applied the load on the soil, okay, so in that sense, there will be an heaving, okay, occur, okay, or the soil will behave as a swell conditions, okay. So when we upload or decrease the number of the load, okay, so the soil we try to will heave upwards, okay. So kalau sebelum ni dia turun ke deform ke bawah. So selepas kita reload, okay, so a little bit of the deformations occur upwards, okay, from the previous conditions, okay. So normally in elastic, okay, when we reload in the elastic behavior or in the elastic zone, okay, so the soil can tend, okay, to deform backward, okay, but it cannot deform or cannot go to the first conditions. Okay, dia tak boleh kembali kepada keadaan asal. Okay, so load, unload, load, unload. Okay, load, unload. But under the plastic condition, so if we unload, so due to the soil has reached the failure state, so it will not deform as same with the elastic conditions. Okay. So in this topic, we discuss more on the settlement. Okay. However, we not discuss on the heaving because heaving is not a really a big issue in constructions. Okay. Okay. So the component of total settlement. Okay, we have three components here. Okay. The first one is the immediate settlement. Okay. Then we have a consolidation settlement. Later on, continue with the secondary compressions. Okay. So normally, practically, okay, this behavior or this determination should be sorry, saya tak ada pen. Saya pakai ni. Should be only consider, okay, for the clay material. Okay, SI, SC, and SS. Okay. So, however, for this subject, okay, I will discuss only on the SI and SC. Okay, secondary compression we will not discuss in this topic. Okay. Then for a clay, okay, sorry, for a sand, okay, we only consider or count for the SI or immediate settlement only. Okay. Due to the particle of the sand relatively bigger compared to the clay because it's not considered as a fine material. Okay. So in that case, okay, there will be no consolidation settlement and secondary compression occur in a sand layer. Okay. So today we may discuss only on this immediate settlement. Okay, how to calculate the immediate settlement for the clay and also for the sand. Okay, if you have any question, you can interrupt during my session. Okay. So a brief explanations on the immediate settlement, primary consolidations, and secondary consolidations. Okay. So once we apply a load on soil, okay, so the immediate settlement will be occur. Okay. So later on, okay, it may continue with the primary consolidations. Okay. So right after we apply a load, immediate settlement happen. Okay. So we may use an equation, okay, to calculate for the immediate settlement. Okay. However, immediate settlement is not a very significant to the clay. However, it's very significant to the sand materials. Okay. So then it may continue with the primary consolidations. Okay. So normally, okay, with a high groundwater level, okay, the material of the clay, okay, we can consider 100% saturated. Okay. So due to the load applied on the soil layer, okay, under a certain time of period, okay, the process of compressions, okay, we continue, okay, and it will make the water, okay, extrude out from the voids, okay, in the soil as a result of increased loading, okay, or as a result due to the longer time of periods where we apply the loads, okay. So meaning that consolidations, okay, is dependent to time, okay, which is a longer time that we apply the load, okay. So we need to count, okay, how long the process of consolidation will be completed, okay. So consolidation depends on the thickness of the clay layer, okay, and also the consolidation characteristic. Okay, so nanti awak akan belajar macam mana nak kira process of consolidation, which is a primary consolidation. Berapa lama dia ambil, berapa settlement yang akan berlaku, okay. Adakah settlement tersebut melebihi daripada apa yang diletakkan di dalam garis panduan untuk building design. Okay. Dr. Dayang beritahu kelas ni 100% local. So my lecture I will mix within Malay and English lah. Okay, but my slide totally in English. Okay. So you just imagine, okay, you have a sponge, okay, then you wet the sponge 100%, okay, and then you apply a load on the sponge, okay, then you can see that the water start to uh, exit from the sponge material. Okay. However, they still have a remain or they still have a water inside the sponge, okay, which is this water and the sponge material, okay, allow or cater for the load applied on its fabrics or its material. Okay. So then if you increase more, so there will be an extrusion of water, okay, from the same material, okay, and they still have a remain a water inside the sponge. Okay. So begitulah keadaan apabila kita apply load on a saturated soil. Okay. So the process which is I have mentioned before depends on the thickness and also the consolidation characteristic. Okay. So one, it completed the primary consolidation. Okay. The secondary consolidation will be continued. Okay. So the secondary consolidations, okay, where in this condition, okay, the soil fabric, okay, start to readjust their positions. Okay. So in this secondary consolidation, okay, um, the soil fabric, okay, play the main important role, okay, in to cater for the load applied on the soil. Okay. However, the magnitude is very small, okay, and the rate of the deformation is very low. Okay. So normally for secondary consolidations, okay, we consider when we have a reclaim area, okay, kita perlu ambil uh, the properties of the secondary consolidation, okay, when we construct or we want to develop a new area under a reclaimed soil, okay, kawasan yang ditambak lah. Okay. Okay. Okay, the process we call as a compression, okay, where we apply a load and the soil will compress. Okay. The compression of the soil is due to elastic deformation. Okay, because this we will not apply a load, okay, up to the ultimate limit state conditions. Okay, so it is still behave under the elastic deformations. Okay, and the deformation of soil grains is very small, okay, and negligible, okay, which is it only happen under the secondary compressions. Okay. Sebab tu dia berlaku dalam keadaan yang ketiga. Okay. So keadaan pertama dan kedua diambil oleh air dan air itu akan keluar daripada tanah apabila air tersebut telah memenuhi voids yang ada di dalam tanah. Okay. So compression of water, air and water in the voids, okay, water is incompressible. Okay. So kalau terlebih dia akan keluar sendiri. Okay. So kalau tidak diperlukan. Maknanya kalau voids tu perlu dipenuhi oleh air. So jika tidak diperlukan dia akan keluar. Okay. So then we need to imagine there are two process of compressibility, okay, in that I guess most of you already know, which is the compaction. Okay. And the one that you are now looking at is the consolidation. Okay. So kalau compaction, sorry, awak belum masuk ETM lagi kan? Hello?
Belum, Doktor.
Belum. So awak daftar hari pertama tu macam mana? Online semua?
Doktor.
Oh, ada laptop? Dah ada saja. Nanti semester depan awak akan masuk ETM, betul? Tahu tak? Yelah, kena bergurau juga nanti kan awak tak dengar apa saya cakap. Semester depan tahu tak yang awak akan masuk ETM?
Tahu, Doktor.
So nanti, yelah awak tak jumpa saya lah semester ni. Okay. So, compaction dah belajar? Masa lab? Tak ingat? Ingat tak? Mesti dah belajar kan? Awak dah masuk Mama 1 kan? Yelah Mama 1 secara maya lah.
Rasanya ada yang dah, ada yang belum sebab kita orang asing-asing kumpulan.
Kejap ni kumpulan mana ni? Saya dah confused ni. Awak berapa kumpulan ni?
Kan Doktor, subjek lab tu dia bahagikan kepada beberapa kumpulan. So ada minggu ni
Oh, sekarang tengah berlangsung lah.
Doktor,
Bukan
tengah
Mama
berlangsung.
saya. Awak tahun 2. Okey, tak apa. Okay, so kalau compaction, okay, we call as a we use a standard proto compaction method lah. Okay, we call as standard proto compaction methods. Okay, so then we plot a graph, okay, which is dry density. Nanti awak ingatkan saya, takut saya cakap-cakap ni kan awak ada kelas apa ni kan. And water content, okay. So you need to produce a graph, okay, which is dry density versus water content. Then usually the pattern of this graph we call as a bell-shaped pattern. Okay, dipanggil entah loceng. Okay, panggil loceng sikit. Then, okay, in order to ensure that your compactions testing is following the standard procedure, or you gain a standard result, okay. So you need to compare, or you need to draw we call as a void curve. Okay. So a void curve, zero a void curve. Okay. Okay, zero a void curve. Okay. So this zero a void curve, okay. In this part, okay, part ini kita namakan sebagai saturated punya condition. Okay. So your compaction curve could not exceed this a void curve. Okay. Whatever effort that you apply, okay, using using a modified method, so definitely you may not crossing this a void content curve. Okay. Why? Because under the compaction, okay, you only allow the effort only allow for the air, okay, to exit or to exit from the pores. Okay. Okay. And the difference between the consolidation, okay, first, the procedure is definitely different, okay, because the compaction we not 100% saturated the sample, okay. And for consolidation, we 100% consolidate sample, okay, and then we apply a load, okay, for a very longer time, okay, because for the compaction, only 10 or less than 10 minutes the testing. While for the consolidations, okay, for one single loading, okay, we need to spend 1 day or 24 hours. Okay. So the consolidation, the process allow for the dissipation of pore water. Okay. So that is the difference between compaction and consolidation. However, both of them are considered as a compressibility efforts. Okay. Kedua-duanya adalah kita proses untuk kita apply loading. Okay. So that is the difference between compaction and consolidations. Okay. So kalau ada soalan, explanations, okay, during your final, so you need to explain, yeah, if there are question asking on the difference between compaction and consolidation, okay, it's better for you to draw a sketch for the compaction, this kind of curve. While for the consolidation, you may learn later on, then you need to know how to sketch it to show, okay, the difference between the compaction and consolidations. Okay. Ada yang duduk kat ETM sekarang? Ada? Tak ada? Ada? Oh, betul-betul puasa kan, senyap lah.
Ada betul.
Kalau awak nak datang jumpa, datang bilik saya boleh je. Ialah kalau nak jumpa. Dan kalau tak faham apa saya terang ni. Okay. So if set, okay, now we discuss on the immediate settlement. Okay. So saya akan bagi contoh. Saya rasa ada contoh untuk sen tak ada diberikan dalam buku Dr. Kamarudin. Sebelum tu semua dah ada buku Dr. Kamarudin. 1, 2, 3, 4, 5, 6, 7, 8. Memang ada delay Oh, kat tangan. Oh, okey, bagus. Oh, canggih. Okay. So pastikan semua dah ada, nanti saya akan gunakan Mungkin untuk slide ni saya akan ambil 1 minggu, minggu ni tak habis. Minggu depan saya habiskan semua slide. Lepas tu awak balik raya kan? Balik raya. Lepas tu next punya meeting, okay, kita akan gunakan buku Dr. Kamarudin. Okay. Sebab tu semua mesti ada buku Dr. Kamarudin, simpan. Nanti mungkin awak akan guna waktu teknik 2. Teknik 2 pun simpan sehinggalah awak graduate. Nanti awak akan guna masa kerja. Okay. Okay, so kita tengok on immediate settlement. Okay, settlement ni penting. Okay. Awak tahu cara nak kira settlement. Nanti awak boleh gunakan untuk IDP. Nanti awak ada subjek IDP lah. Okay. So, if saturated clay is loaded rapidly, okay, the soil will deform with virtually no volume change due to without any dissipation of water from the soil. Okay. So, secara apa, mata kasar kita tak nampak lah perubahan yang berlaku ke atas tanah. Okay. Sebab dia berlaku dalam keadaan yang diistilahkan cepat. Okay. So, tetapi kita boleh kira, we can determine the magnitudes for this immediate settlement, okay, by using an equation, okay, which is definitely different between clay and sand. Okay. Okay, so this is the equation, okay, to calculate for the immediate settlement. Okay. So whatever equation that you receive, okay, the first thing is to make sure that the left and the side for the left and the side, okay, of the equation should have the same units, okay, when you try to solve it, okay. So kalau S settlement, definitely di dalam unit meter lah, kita ambil meter lah. Okay. So saya nak tanya awak balik, awak ingat tak ni? Okay. Q ni represent apa? Kalau dalam kelas, tak boleh nak lari kan? Yang ini, saya pun bukan tak nak tengok muka awak. Nanti kan ambil masa, dia delay lah kalau internet. Yang setakat ni yang depan saya punya ni, Afiq, Aina, Ami. Yang lain saya tak boleh keluar sebab saya pakai satu skrin saja. Okay, Q0 ni apa? Sebab siapa boleh jawab? Siapa boleh jawab? Dia boleh buka pukul 7.11 malam ni. Johor lah. Ada siapa sini duduk Sabah? Tak ada. Saya kena hantar, kalau lecturer UiT ni bagus ni ajar awak ni. Senyap awak ni. Baiklah, awak tahu UTM ni nombor 1 tau dalam Malaysia untuk civil ni. Nombor 1 kena cergas lah. Awak bayangkan kita ada 20 universiti, kita nombor 1. Dalam dunia kita nombor 50 ke 100. Berkemungkinan nombor 80 kot dalam dunia. Dan nombor 1 dalam Malaysia untuk civil Dalam Asia kita nombor pada ASEAN kita nombor 7 So ganas lah ITM ni. Tapi senyap lah. Okay, Q-note apa Q-note? Tak ada agak?
Pressure. Pressure.
Okay, betul lah. Okay. So you need to differentiate between, for example, capital Q and small letter q. Okay. So normally for capital Q, kita akan namakan sebagai load lah. So the magnitude is kilonewtons. Okay. So kalau untuk small letter q, okay, so the magnitudes normally is kilonewton per meter square. Okay, we can call as a pressure or stress. Okay, okay. So begitulah unit dia. So if this is small letter q, so the unit is kilonewton per meter square. Okay. Sorry lah kalau siapa yang dah biasa jadi boring kan, tapi kita buat so slow lah. Okay. So yang mengajar pun lagi boring sebenarnya. Sebab dah tak nampak muka kan. Okay. So kilonewton per meter square. Okay. Then B, okay, B meter lah kan. The width, the breadth, okay, of the foundations. So meter, okay. Then kita divide dengan E. Okay. E ni apa? Yang modulus kan? Yang modulus apa unit yang modulus? Ada unit tak? Cepat. What is the unit for the young modulus? Awak dah belajar material kan? Tak ada, tak tahu. Ada mana? Siapa ada duduk Kelantan ni? Ada? Dah tengok cerita apa? Pok Ya. Korang TV tak tengok semua ya? Hanya study. Okay, kalau study pun tak boleh jawab eh? So what is the unit of E? KN, okay. Okay, lagi siapa nak guess lagi? What is the unit of E? Okay, how can we get the E? Or how the E obtain? Tadi kan saya dah cerita pasal stress strain curve kan?
Over strength.
Stress strain curve kan? Okay, definitely kalau stress adalah kilonewton, Afiq Aika Rosli. Banyak awak buat tanda apa? Tanda simbol kan apa? Slash, comma, apa? Saya tak nampak awak tulis apa, Afiq. Okay. Okay. Then, dah terlupa saya. Okay. Kalau kita plot, okay, the pattern, okay. So normally the Young modulus, okay, we try to get the slope, the slope of this elastic pattern, okay. So kalau slope kita akan dapati adalah ratio between stress over strain. So kalau stress over strain, okay, stress adalah kilonewton per meter square. How about the unit for strain?
Unitless.
Oh, unit betul. Aina Azhari, bagus. Okay. So yeah, you can call as a dimensionless pun boleh. Okay. So definitely kilonewton per meter square bahagi dengan, kalau unitless ataupun dimensionless kita letak di simbol lah. Okay. So kita ada kilonewton per meter square. Okay. Tak habis lagi kan? Okay. Kalau ikut betul dah boleh sama, betul tak? Tapi kita ada lagi yang baki-baki ni. Okay, so 1 tolak Poisson ratio. Saya tak canggih lah. Okay. Okay, apa unit bagi Poisson ratio? Dan apakah itu Poisson ratio? Ini sampai pukul 3 belajar ni. Okay, Poisson ratio adalah the ratio between vertical stress over vertical strain over horizontal strain. Maknanya kalau satu material tu kita kita compress dia, okay. So there will be dia akan jadi deform, okay. Yang ni selepas di compress dia, okay. So panjang asal, sorry, kalau untuk vertical strain, okay, L deformation over L. So kalau horizontal strain, kita ambillah delta H over delta, bila nak guna H boleh, B lah B. Okay, over B, horizontal. Okay. So that is for the Poisson ratio. So Poisson ratio doesn't have any units, so dimensionless as well. Okay, good. Tangent thing, okay. Then the last one is the alpha. Okay, alpha is a coefficient. Normally coefficient doesn't have any units. Okay, so later on we know, okay, or the equation is balanced. Okay, so baru boleh kita tahu equation ni betul ataupun tidak. So equation ni betul sebab kiri dan kanan sama. Okay, kan saya nak ajar setiap kali nampak equation, kita kena tahu what is the derivation of the unit, okay, between right and left punya formula. Okay. So alpha, this alpha, okay, because the rest we can get from the material and from the loading, okay. QE semua ni kita dapat. Okay. However, for the alpha, it depends on the type of the foundations. Okay. Kita ada rigid, kita ada flexible. Okay. So rigid, flexible is not because of the material itself. Okay. It is the behavior of the load. Okay. For example, for a normal structure, we can call as a rigid. They use a rigid foundation type. Okay. Okay, when they are a condition where the loading is extremely change. Okay. Contoh macam tank kan, tank air, silo. Okay, ada masa dia boleh penuh, ada masa dia boleh kurang kan. Okay. So they count as a flexible foundations. Okay. So then that is first. Okay. The second is depends on the thickness. Okay. From the base of the footing, okay, to any hard layer. Okay. So kalau hard layer terlampau jauh, they consider as a infinite thickness. Okay. If the hard layer, okay, have a certain height, for example this H, so we need to divide with the width of the foundations. Okay. So from there we can get the alpha value. Okay, nanti saya share dia punya how to determine the alpha. 10.38 lah. Saya cuba berhenti 10.55 sebab awak nanti nak masuk kelas yang lain kan. Okay. Okay. Okay, so this is the example, okay, how to determine the immediate settlement for the clay. Okay, first when we read the question, okay, so we try to retrieve as many information from the question itself. Okay, contoh rigid foundation. Okay, saya dah beritahu tadi kan sebab dia akan mempengaruhi the alpha value. Okay. Okay, the size of the footing is 3 times 3. Okay, and the uniform load is 1,800 kilonewton. Okay, it's lying on the compressible medium soft clay layer of infinite thickness. Okay, tadi saya dah beritahu alpha dipengaruhi oleh thickness. Okay, so in this question they have mentioned that the layer is infinite thickness. Okay, the under elastic modulus, okay, this is the elastic modulus, mega, ni kilo. So if mega means that 1 million kan? Betul tak? 1000 lah, betul lah, 1 million, mega. Okay. So PA is the Pascal, okay, which is actually same with the Newton per meter square. Okay. So PA, sebab saya ingat lagi masa dulu saya pernah yalah, lepas saya dah ajar sebab tu saya jaga periksa. So ada student tanya macam nak tukarkan PA kepada uh, Newton meter square. Okay. So dah memang sama, tak perlu tukar lah. Okay. So Poisson ratio is 0.5. Okay. Determine the average immediate settlement under this foundation. Okay. So tambahan, dia menyatakan immediate settlement. Okay. So 1, this is square, 2, infinite, 3, 4, immediate. So benda ni semua mempengaruhi nilai alpha. Nanti saya tunjukkan table Okay. So nak selesaikan soalan yang ini, okay, based on the equation, okay, so awak berhati-hati kalau diberi nilai load, okay, dan area 1,800 ni bukan nilai Q ni lah, bukan nilai Q ni. Q ni adalah 1,800 bahagi dengan 9. Okay. So then we have berapa ni? 200 kilonewton per meter square or 200 kilopascal. Okay. So then times dengan B. Okay, sorry. Ni times dengan B. Okay. Kita akan dapat the first up part area. Okay. Then we divide with the 40,000. Okay. Because we need to use the same units. Okay. So kalau ini kilonewton daripada megapascal perlu ditukar kepada kilopascal, okay? Ataupun kilonewton per meter square. So dia akan jadi 40,000. 1 minus 0.5 square, okay? Poisson ratio 0.5, okay? Then the CS or the alpha, okay? So the CS or alpha ni, okay? Mana datang 0.82? Okay. So saya tunjuk table tersebut. Datangnya 0.2 daripada satu table yang saya akan tunjuk depan ni. Sekejap Saya stop sharing dulu. Okay. So saya buka yang ini. Yang ni saya dah masukkan dalam awak punya e-learning Dr. Ryan tak guna e-learning kan?
Tak, doktor.
Tak. Oh, memang ada 10 saat delay Itu masalah internet ni. Sekejap Okey, nampak ni. Okay. So untuk alpha, okay, dia ada dua table, table 4.1 and table 4.2. Okay. So the caption of the table 4.1, okay, at the last sentence, they mention on the infinite depth. Okay. While for the 4.2, okay, a limited depth. Okay. So in our case, okay, as mentioned in the slide, okay, it is a infinite depth. Okay. Okay. So kalau untuk infinite depth, information tambahan yang kita tahu adalah rigid foundation, kan? Okay. So for the rigid foundation, okay, we have several type of foundation here. Circle, square, rectangular, okay. So for our case, the size of the shape of the foundation is square. Okay. Then the loads or the settlement the settlement that we want to consider, okay, in for the problems, okay, is under the average value. Okay. So when we look on the square average, okay, the alpha should be 0.82. Okay. So sama tadi kan? 0.82. Okay. So that is the alpha value. Okay. Kira lah. Bawang dapatlah 0.0092. So kalau jadikan dalam milimeter, betul tak? Dua kali kan? 0.9 per milimeter. Okay. So this consider as apa ni? Mili kalau nak jadikan dia jadi 1 titik apa tak ada titik perpuluhan 9.2 micro micrometer kan. Okay. So very tiny lah movement dia, deformation dia. It deform very too small. Okay. 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 Faham? Ada soalan? Siapa ada soalan? Awak nampak tak session ni? Nampak kan? Okay, tak ada soalan Okay. Itu adalah untuk CLI. Saya rasa untuk SEN ni saya hanya dapat sempat introduce je lah. Sebab calculation dia panjang. Okay. Okay, ni adalah untuk SEN Yang ini diperkenalkan oleh Sherman. Okay. Untuk mengira settlement bagi SEN, kita kira sekali saja, which is under the immediate settlement of footing on SEN. Bagaimanapun nak kira dia ambil masa. Okay. So for example, as I is the settlement. Okay. Cuba kita buat balik. Okay. So C1. Okay. So this is M. So saya ambilkan masa cerita pasal benda ni lah. Okay. This will be your M. Okay. So C1 is what we call as based on this equation. Okay. So 1 minus 0.5. Okay, stress over stress. So kita letak dia sebagai dimensionless lah. Okay. So C2. Okay. It is a time. Okay. So at the end the time is not related to the what we call as to the deformation. So in this case we also consider as a 1. Okay. So maksudnya untuk settlement bagi SEN, okay, if you want to consider for certain period of time, okay, so we put the information on this time in year. Okay, for example, if 5 years, what will happen to the settlement of the SEN? Okay, so we put 5 years here. Okay, then we start to calculate for the rest. We gain the immediate settlement. Okay, after we complete for the rest calculation. Okay. So yang ini Q0 minus Q. Okay. So this should be in KPA lah. Okay. Definitely I is the coefficient, so it doesn't have any units. However, divide with the Young modulus. Okay. As I told you before, Young modulus is the KPA. Okay. So we have your KPA. Okay. And this should be 1. Okay. Then this is the changes of depth. Okay. So the magnitude is meter. Okay. Okay, so kalau yang ni kita selesaikan, so kita dapat meter equal to meter. Okay. Faham? Faham kan? Okay, untuk immediate settlement of SEN, okay, kita ada 2 type of footing. Okay. The first one is the square and circular footing. Okay. So we look on this solid line. Dalam this sebagai solid line. Okay, ini adalah solid line yang digunakan untuk tentukan nilai IZ. Okay, this IZ is the coefficient only, influence factor. Okay, to be put on these equations, which is the value. Okay, so what is the value of the IZ under square and circular footing? Okay, so based on the diagram, okay, we may refer to this value. Okay. So for example, if the Isaac, if at Z 0, the Isaac is equal to 0.1. Okay. Okay. So this is not on the scale. Okay. Kalau awak nak buat proper, awak put in the scale. Okay. So then we have another one, 0.5 for the Isaac at 0.5b. Okay. So for example, if the width of your footing is 2 meter, so yang ini lebih kurang kedalaman 1 meter. Okay. So then the last one is Isaac is equal to 0. Okay. When the Z is equal to 2b. Okay. So 2b kalau 2 meter, so dia akan jadi 4 meter. Okay. Tak apa, yang ni awak digest ini dulu. Nanti kita akan pergi kepada example next week. Okay. So that is for the square and circular footing. Okay. While for a slip footing, okay, slip footing ni satu footing yang mana dia terlampau panjang berbanding dengan lebar. Okay. Dan normally kalau untuk square and circular footing, dia hanya ada satu column saja. So straight footing, okay, awak imagine macam pagar lah, macam tiang, pagar batu tu. Dia ada beberapa series of tiang, okay, dan tapi dia menggunakan satu footing yang panjang. Okay. So they consider as a straight footing if the L over B greater than 10. Okay. Mana kalau panjang dia 55, lebar dia 10, contoh kita ambil yang mudah lah. So 55 bagi lebar dia 5, 55 bagi 5, so jadi 11. So that would be considered as a straight footing. Okay, for the straight footing, okay. So this is the value for the Isaac 0 Isaac 0.5 ZB Isaac 0 ZB equal to 4. Okay. So it means that, okay, to ease your calculation, okay, for this Isaac over ES delta Z, so we can put in two groups. Okay, the first group is here. Okay, so get all the information and get the average, and then divide with the ES average as well, and the depth of the Z, okay, is between 0 to which is B over 2 minus 0. Okay, then the other group is from B over 2 to 2B. Okay, so nanti saya akan tunjukkan contoh. Okay, then you may know how to get the immediate settlement for this sand material. Okay, itu kita akan bincang next week. Okay, ada soalan sebelum kita bersurai? Ada soalan? Tak ada. Okay, tunjuk apa thumbs up tu, maknanya tak ada masalah. So, okay, ada apa masalah boleh share dalam grup ataupun personal, ataupun kalau awak nak datang ke bilik saya pun boleh. Okay, so setakat tu saja untuk pagi ni. So, kepada yang Muslim, selamat berbuka lah pukul 7.11 waktu Johor. Okay, so Assalamualaikum and good morning. Stop.